Hello everyone. In this video, we will see the derivation of LVISDT, which stands for date of last visit. So this video is part of derivation of key date variables, which are commonly used in ADSL. And in earlier videos, we have seen RFICDT and RANDT, which were based on disposition dataset. And we have also seen TRT-SDT and TRT-EDT, which were based on SDTM exposure dataset. And then we have seen an example which was using SDTM SV dataset, and that variable was FVISDT, date of first visit. And this LVISDT is also based on SDTM SV dataset. Let us take a look at the specification of the derivation algorithm provided for LVISDT. So it says using SV dataset of SDTM SV, which means here we are being asked to use SDTM SV dataset, and then the derivation says get LVISDT as numeric of date part of maximum of SVSTDTC and SVENDTC of a subject. So if on a particular record we'll have both the dates, so we are being asked to use the maximum of SVSTDTC and SVENDTC and pick the latest value from these two dates. So we have been given some details which says if a subject has started a visit but not ended the visit yet, ongoing visit. So picking the last visit date solely by SVE and DTC will not provide accurate information. So a combination of SVST and SVE and DTC has to be used to pick the latest available date for a subject in SV. So they are mentioning that in some cases only SVST could be populated on the records with SVE and DTC being null. So in such cases, the last visit value has to be actually used from SVSTDTC, because we know that the subject has started that visit and may end on the same day or may not. So if we use a maximum of SVSTDTC and SVNDTC on that record and then use the latest date available across all records, we would get the last known date across these two variables, which will be our LVISDT. So let us take a look at the data and manually try to derive SV LVISDT for the subjects which we have in our demographics dataset. This is the same set of raw data which we were using for other previous videos in this series. So here we have three subjects: 1001, 1002 and 1003. So this variable is based on SV dataset. Let us take a look at the SV dataset. And then let's try to identify the LVISDT for the first subject, 1001 first. So let us try to manually filter that and then see the latest date across all these four columns, or or these four cells, which is SVST, DTC, SVE and DTC, maximum of these four. So all these four cells seems to be on the same date, which is 29 September 2011. So for this subject, the latest date would be, or the LVISDT would be 29 September 2011. So let us try to put that in our form which we were using to keep track of all the derived variables as part of this video series. So this is 29 September 2011. Let us do the same thing for our subject 1002. Let us filter for 1002. So we have different dates here. So some dates are in 2011 and some dates are in 2012. So 2012, let's see what are the months available. So 2012 January, February, March, and again here there are few records in March. So 2012 March 1st, 2012 March. So we are looking for records which fall in March. Let us try to temporarily highlight those records which are in March. So March, again this is in March. So March will be the latest month, and within March we have 1st March, 15th March and two instances. So the latest of these three values, or across all these date values, is 15th March. So the date value will be 2012 March 15th for the second subject. Let let us try to put this here in the form, and then let us try to do the same thing for our subject 1003. Let us filter for subject 1003, and then let's take a look at the year first. So all the date value seems to be from year 2011. Then now let us take a look at the months. So we have data from September, we have data in October. So September, October, and there is this date in November. So the latest month would be November. Let's take a look at all the data values once again and see if there is any other value in November. So there seems to be only one date value in November, that is 1st November. So the latest date for this subject based on our manual identification is 1st November 2011. Let us try to put this in the form. So 1st November 2011. Now let us take a look at the programming approach that can be used to derive SVE and LVISDT using SV dataset. So we have our SV dataset. As per the specification, the details provided in the specification, it was mentioned that there can be some SVE and SVE and DTC values missing, but SVSTDTC is present. So what I am trying to do here is, like, on such cases when SVE and DTC is missing, I am carrying forward the SVSTDTC value into SVE and DTC, and then use the latest value in SVE and DTC. For the instances where SVE and DTC is missing, SVSTDTC has to be considered for the LVISDT variable. So we are getting the required values into a single variable, that is SVE and DTC, and then sorting the data set and also making sure that just in case, even after doing this processing, if we have any and missing dates in SV and DTC, we are excluding those records with a where statement within the proc sort. We are sorting the records based on U sub JD and SVE and DTC. With this sorting, what happens is, like, within a subject, the earliest dates get sorted on the top, and the latest dates get sorted at the end. So after this, we are employing a data step and using by group processing within it. And based on the previous sort, we know that the latest date available within a subject gets sorted at the end. So we are employing if last at sub jd, which is a subsetting if statement using the temporary variables which gets created based on the by group processing and subsetting those record. And after that, in case if we have both date and time components in that variable, we were asked only to consider the date portion. So we are using substrn function to extract the first 10 characters which correspond to the date component within a DTC's date time values. So we are extracting that and then converting it into numeric format using input function and yymmdd10.in format, and then applying a date9 format to the newly created numeric variable LVISDT. And as we only need this LVISDT variable along with the subject identifier, we are keeping only those two variables here. Again, as discussed in the previous videos, we can merge this dataset to the previously derived variables and then have LVISDT populated in that dataset. So let us now execute this dataset and see what are the values we are getting based on our programming implementation, and then try to compare those dates with the manually identified dates. So we need to look at LVISDT dataset. So we have 29 September for subject 1001, 15th March for subject 1002, and 1st November for 2011. 29 September, 15th March, and 1st November. So 29 September, 15th March, and 1st November 2011. So we were able to get the same result achieved programmatically. So this is how we can derive LVISDT variable in ADSL when required.